Hi, I'm Mr. Huber, and in this video we're going to talk about problem 5. The mass m kilograms of a radioactive substance at time t days is given by m in terms of t is equal to 5 times e to the minus 0.13 t. What is the initial mass? After how many days is the substance for the first time below 0.5 kilograms? Give the answer in whole days. Work out the daily decay factor and the daily decay percentage. Well, look, scientists love this notation. Well, it's not clear to us at the moment why they love it so much, but in year 6 and year 7 we will understand it. Oh well, you'll see something in the end of this video that will explain how you can rewrite it in a form so that we can understand it. Now, what's the initial mass? Well, that couldn't be easier. You just plug in 0. At time t is equal to 0, you plug in 0. Once you plug in 0, this will be e to the 0. E to the 0 is 1, so it will be 5 kilograms. B. After how many days is the substance for the first time below 0.5 kilograms? Okay, well, m in terms of t, the mass in terms of t, of the time. You plug in this term here, and we want to isolate t eventually. So first we divide by 5. This is what we get. Then we apply the ln on both sides. Well, once you apply the ln on both sides, you're going to get this directly. Why is that again? Because look, ln of e to the minus 0.13 t. The question here is, e to the what is e to the minus 0.13 t? Well, that's obviously minus 0.13 t. But if you used this method here, taking out the exponent and writing the ln e over here, that would lead to the same thing, because ln e is 1, because e to the what is e? Well, e to the 1 is e, so you would get 0.13 t as well. But you can do it directly. So now, look here, we can clearly see that we have to divide by a negative number, which means that we have to change the sign, and we're going to get approximately 17.71 days, I believe it was. Yes, days. So t is 18 days. Now work out the daily decay factor and the daily decay percentage. Now look, this is the function that we were given. And normally, this up here will show us the daily decay factor and the decay percentage. So what we do is we take that part of the function, we rewrite it like this: e to the minus 0.13 to the t is approximately to this, approximately equal to this. Now look, the exponential decay factor is now 0.8781. That's the exponential decay factor, the daily decay factor. That means it's 87.81%, and we're going to lose 12.19% per day. And there is one other important, very important thing here. Look, you could write m of t, 5e to the minus 0.13 t, as m of t, 5 times 0.8781 to the t. Clearly, for us at the moment, this notation is much clearer and much better, because we can see this is the daily decay factor, the daily exponential decay factor here. So that means after 1 day, we're left with 87.81% of the amount of the previous day. And we can see that we're losing 12.19% per day. That's the daily decay percentage. So you can always rewrite this as this, and you could go the other way around and rewrite this as this. As I said, for scientists later on and mathematicians, this is more convenient. But well, at the moment, this one speaks much more to us because we can see what the daily decay factor is and what the daily decay percentage is. Okay, I hope it wasn't too difficult. See you on the next one.